Hi everyone, in this new tutorial I am going to show you how to calculate the base shear of each of these floors in your building using the software SAP2000. This function is not included within the software. It's included in the other software as ETABS, and Patreon asked me about this, if it is possible this to calculate in SAP2000. So I would like to share with you some tricks and tips to calculate these forces on each level. Okay, so to do this, first of all, I'm going to add in a load pattern, lateral load pattern. Usually the base shear is estimated into seismic analysis. So I would like to add an earthquake load in the x direction. I'm going to consider as other just 0 on self weight multiplier. Okay, and I'm going to add some forces, some lateral forces. In this case, we're going to consider for this floor 30 tons. And in these floors, I'm going to consider 20 tons per node. And over here, I'm going to consider 10 tons on each node. These are only just example values. You need to use, of course, your seismic code, which indicates which is the seismic coefficient, or use a response spectrum to apply the seismic forces. Okay, so now we have a load pattern, a lateral load pattern in our building, and we would like to calculate the base shear on each floor, right? So we would like to know which is the base shear on this floor, for example, exactly in the bottom of the columns, and the same here. Of course, if we made a manual estimation, we will think that the base shear on these points are going to be the sum of these three loads, right? 90 tons. So to do this calculation, we need to define groups, first of all. So we're going to define groups here. This will be our first floor, okay? So we're going to define groups. I'm going to add a group called F1, first floor, and we're going to add an F2, F3, F4, and 5. Okay, now we need to assign this, assign to group, and we're considering as a group all the columns in that floor and the bottom nodes. We need to respect this convention in order to get the loads in the bottom of the columns. Okay, so we're going to assign our first floor, then we select these floors, these columns, and these nodes as our second floor, third one, fourth, and the top one, 5. Okay, now as we have groups, we need to create section cuts. Okay, what is a section cut? Section cut, it's a way of that allows you to integrate an amount of loads between or among the nodes that you select. Okay, you can select something, or you can create groups. For example, I'm going to define a section cut, and in this case I'm going to name only section cut 1. here you can select if this section code are going to contain a group, or you want to select a specific plane. You can add your coordinates to create a specific plane to cut the elements and to get the forces. In this case, we have groups. So which group? For section code 1, I'm going to select my group F1, equivalent to this floor. Now, the software asks about if we want analysis forces or we want design forces. Well, in this case, we are going to select analysis forces because design forces are think more for elements. When you have finite element models, for example, you can select an amount of nodes that represent a beam, and you can get the axial forces, the shear load, or torsion, or moments. You can integrate all the forces in the finite element model. Okay, in this case, we're considering only this option, and the other are only default. Okay, section code, orientation, all in by default. Okay, we're going to select a new section code, and now we select group 2, and we need to do this for the 5 floors. This is the 4th and the 5th. Okay. Now we have the 5 section cuts, and now we can run our analysis. Let's check our results. I think everything's okay. And we can review now the tables. We are going to select our load pattern and select here section code forces in other inputs, section code forces. Okay. Oh, sorry, I think I committed a mistake. Let me see where I add loads. Oh, there is just one moment here. Maybe one of this. Oh, I think it's signed on the EX1 load cases. Yeah, load case 1. It's taken our load pattern EX, and this one is a previous that I made for a test and does not contain anything. So I'm going to delete this one and delete this one. Okay, I'm going to change the name for this only to EX. Now, yes, I'm going to rerun the analysis. And now I have only one load case. Display tables, as I mentioned, and other outputs, section code forces, and there is our load case, and you can see. And now we have this F1 are the base shear in X direction. Here are near 0. These are the base shear in other direction. This is vertical load, the moments for every floor. Okay, now you can check this. As I mentioned, the loads that we applied are these ones. Let me show you this here. These are the loads, and you can check, for example, you can take this and review the 5th floor, and you can see 90 base shear, 3 times 30. Then you can get, for example, the base shear in the 1st floor. It should be, you have 90 plus 60, 60, 60. Then you have 30 plus 30, 30 plus 30, and you get 270 tons, which is consistent with our calculation in the software. Then you can get the base shear here, which is 270 minus 30, right? 240. And then you can check the other floors. For example, 240, you can obtain the base shear here. You need to um, um, remove 30 again, and you get 210. Okay, that is the verification. Now, if you diminish the value on a 60, in this case, you are going to get the base shear just in this floor. 60 and 150, which is the fourth floor. And if you want to reach the fifth floor, you need to minus 150 minus 60 again, and you get 90, which is the same here. And that's how we can check our base shear with very simple steps, and you can obtain by each floor your list of base shear. Okay, you can also review it, for example, by reviewing the base shear on each element, and you can get the shear in each column. If you sum all the base shears, you should obtain the base shear. Okay. For example, if you have here you have a 10, 10, 10, 10 here, 10 tons, so you have 60. Here you have 5 and 5. So you have 15, 15, you have 30, plus 60, 90. You have the 90 tons. And you can verify that within between all the floors. Okay. I hope that this can be useful for you. I always open for new tutorials, so if you have any doubt, please let me know, and I can see if I can what I can do for you. Okay. That's all for now. Have a great day. Bye bye.